Everyone loves the Raspberry Pi. I mean, how could you not? You can use it as a gaming station, to run Home Assistant like I do, or create awesome electronics projects around it. The possibilities are truly endless. But technology never stands still, and that got me wondering, what could be the next big thing after the Raspberry Pi? And while browsing through the newest development boards on Mouser, I stumbled across this NXP single board computer that offers similar specs, some wild improvements, and somehow even comes in at a lower price point. So of course I had to get myself such a board. And while I was at it, I also got myself 3 more dev kits built around the newest technologies and ICs. So in this 4th installment of my Future Tech video series, we will check out all of them to find out where technology is heading and whether any of them could be useful for your next projects. Let's get started! This video is sponsored by Mouser Electronics, who not only offer the newest future tech development boards for you to check out, but they're also currently hosting a small giveaway, where you have to test your memory to get a chance to win an FPGA development kit. So click the link below to sign up today, and while you're already there, why not have a look at their massive electronics selection? Maybe there's something there for your next project. Now let's get started with the i.MX95 board from NXP, whose name actually comes from its used chip in the middle, the i.MX95, which is a custom applications processor that comes with quite a bit of functionality under its hood. And speaking of functionality, it is kind of crazy what this board can all do and connect to. We of course got the classics like USB-C, USB-A, Ethernet and HDMI. But then we also got things like LVDS for video, a CAN bus, I2C, an ADC, LED control, real-time clock and quite a bit more. That of course not only makes the board bigger in comparison to Raspberry Pi, but it also makes it more attractive for embedded and industrial applications. But before getting lost in the theory here, let's instead rather hook up a display and give this board power. And yeah, it booted up without a problem, but needless to say, I think my display is a bit too small. So I moved over to a proper monitor, and while I was at it, I also hooked up a USB webcam to the board. I did that because the board comes with tons of machine learning examples, which includes image classification, object detection, emotion detection, and quite a bit more, including my favorite one that judges whether I'm still a driver that is paying attention to the road. And while all these examples are quite demanding, the frame rate was always at 30 FPS. The reason for that is that the i.MX95 board comes with an integrated NPU, or Neural Processing Unit, that a Raspberry Pi for example does not offer. So if we do pretty much the same test with a Raspberry Pi 5, then you can see that the frame rate is not that smooth. However, it is noteworthy that the CPU of the Raspberry Pi is a bit more powerful, which I proved by doing the same CPU benchmark on both boards, and as you can see, the Pi is around 30% faster. And that fits well with its general computing purpose, while the i.MX95 is more focused on embedded and machine learning applications. And for that, the chip also contains dedicated real-time Cortex-M7 and Cortex-M33 cores, meaning Linux, AI and real-time control tasks can all run simultaneously on the same chip. So overall, not a bad choice for more industrial applications. And it should be more or less easy to get started with, because the documentation is not bad at all, and like mentioned before, there are quite a few examples given. But keep in mind, the Raspberry Pi is backed by a large and active community, while the community and ecosystem for this board is more limited. So all in all, it is pretty interesting, but it will certainly not replace the Raspberry Pi, because it is used for different applications. Next I got these two purple packages from Morse Micro that both mention Wi-Fi HaLow. What is that? Well, it is basically IEEE 802.11AH, but I know that explains nothing. Instead, let's say that while traditional Wi-Fi uses 2.4 or 5 GHz, this Wi-Fi uses sub-gigahertz frequencies that, according to the package, lets it allow to reach 10 times further, penetrate through walls 3 to 5 times better, while still delivering a decent data speed. And that sounds amazing, because I actually have tested wireless communication methods before extensively, and the only real long-range solution is LoRa, but its data speed is terrible. But with this Wi-Fi HaLow speed, we should even be capable of streaming video. And speaking of video, my first board here not only comes with the MM8108 Wi-Fi HaLow SoC, but also a microcontroller and a camera. It also comes with way more functionality in the form of various sensors and peripherals, but those shall not be the focus right now. Instead we got the other box that contains a Wi-Fi HaLow USB stick and a router. So after attaching the antennas to both Wi-Fi HaLow systems, I plugged the USB stick into the router and hooked that up to my laptop using an Ethernet cable. There I then adjusted the settings for the router, and once that was done, I moved on to the camera board. Now luckily for me, the developers provided ready to upload example code, and thus it was pretty easy to get this board going and connect to the router access point. And that means all we have to do now is visit its IP address and get greeted by a web server that not only sends over a new captured image every 2 to 3 seconds, but also provides all the other sensor data, like from the accelerometer or temperature one. And truth be told, this is not really a video stream, but it should be enough for testing. But to firstly give you a reference point, I unplugged all my traditional Wi-Fi repeaters and basically only used my main router as the sole Wi-Fi access point. And as you can see, after going into the garden, I was not able to connect to Wi-Fi anymore. Now to test Wi-Fi HaLow, I positioned its router right next to my traditional one and then went outside with the camera board. I even went inside my garden shed in the hope to still send over pictures, but as you can see, that was a bit too ambitious. However, sending over LiDAR sensor data like from the accelerometer was still easily possible, and the average data speed also looked pretty good with around 1 to 2 megabits per second. I even went on a longer walk with this board, and I was able to easily achieve a distance of over 100 meters. And what makes this even more impressive is that we are not talking about a special protocol here, like LoRa. This is still Wi-Fi IP networking, meaning things like web interfaces and MQTT work exactly as you would expect. But of course, we only scratched the surface here, because, for example, router settings vary from region to region, and the given demo code can be further tweaked to find out where the limits of this are. But for now I can say that this is very promising stuff, and best off, the documentation and guides are easy to understand and you got plenty of example code, meaning I'm looking forward to what is to come for Wi-Fi HaLow. And that brings us to the third future tech that kind of looks like a webcam, but it is actually the Onion Tau Lidar camera. After plugging this thing in, all we have to do is install the Tau Lidar server Python module, start the software and open the given URL. Now what the camera delivers is a normal 2D grayscale image, a depth image that through different colors tells us how far the objects are away from the camera, and a point cloud image that, as you can see, creates a 3D representation of the scene. This works because the camera is shooting out infrared light and then receives it back in a matrix whose time of return gets measured, and thus the camera can create this depth map. It is super fun to play around with and also quite trippy, but to be more scientific, I also checked the min and max distance this thing can handle, and it is in line with what the product claims. The software for receiving the data is also open source, so it should not be a problem to use it in your own projects, like for example in a robot that wants to see what is ahead. But then again, this infrared matrix tech is not something really new, and thus not completely future tech. However, I really like what they did here by making this so easy and accessible, and thus it is still pretty awesome. So last but not least, we got this QM33120WDK2 UWB dev kit from Curvo. That is by far the most expensive kit today. But it is also probably the most exciting tech, because inside we find 5 of these white tags and 1 grey tag. When we open them up, then we can see a pretty interesting to look at PCB design, all built around the Murata 2AB SiP that combines a Bluetooth microcontroller with accelerometer and more, with a UWBIC, which stands for ultra wideband. I actually did a dedicated video about that in the past. But to summarize, UWB uses precisely timed radio pulses to measure the distance between these tag antennas. And the grey one is special because it comes with 2 antennas, which allows to not only measure the distance, but also from what direction the radio signal came from, and thus located in a 2D space, kind of like GPS. And indoor GPS is truly what comes to mind when looking at these results. But before getting to that, I firstly had a look at their beautiful online guide that even comes with video footage, and of course all information to write your own code for these things. But I wanted to keep it simple, and thus firstly installed the mentioned phone app before powering up a grey and white tag, which I then configured with the app. Now in this demo you can see how well both tags can measure their distance and angle to one another, and that already seemed promising. I of course also measured the actual distance, and it seems like a tolerance of around 10 cm is to be expected, which is what the manufacturer says as well. So next I tried the actual futuristic demo, with a total of 4 tags on the outside and 1 on the inside. Needless to say, I was a bit limited by the space in my lab, but I think you can already see pretty clear how such a setup can determine the position of the tag in the middle. That means this way you can reliably determine the position of people or objects indoors with pretty good accuracy, and I feel like there are quite a few useful applications for that. So overall, fantastic stuff and a great closure for this future tech episode. I hope you enjoyed it, and as always, thanks for watching. Don't forget to like, share, subscribe, and hit the notification bell. Stay creative, and I will see you next time.